All right, let's simplify a bunch of natural log expressions or exponential expressions. So first of all, there's a bunch of properties you have to remember. I'm going to let you refer back to them, but I'm just going to do these problems quickly. So that number can go down to the front. So that equals 2 times the ln of e. And what's the ln of e?
1.
It's just 1, so this is just 2. The natural log of 0 does not exist. You're not allowed to take the natural log of 0 or negative numbers. It has to be greater than 0. It's not part of the domain. Look at the graph of a natural log function and you'll see. This next one, what's the log base anything of 1 equal to? 0. Because remember what this means is log base e of 1. And what does log base e of 1 mean? It means e to what power equals 1. And what's the answer to that? It's always 0, right? So log base anything of 1 is always 0. This can just be rewritten as ln of e to the negative 3. And just like I did here, now I can take that down to the front. And the ln and the e cancel, so your answer is just negative 3. This is just the natural log of e to the negative 1/3, because that could be rewritten as e to the negative 1/3, right? Which is just equal to negative 1/3. So you'll notice one of the patterns here is the natural log of e to the x is just x. That's one of your properties that basically we're just finding out. And then this one, without overthinking it, I'm just going to tell you, if you take the natural log of e, they cancel out and you just get x. And if you raise e to a natural log, they cancel out and you get 5 and you get whatever you had here. So that's just 5. And I could prove it to you a different way by doing other stuff, but it's just a good property to know. Okay? Whenever you're raising a power to its base, like if you were raising 3 to the log base 3 of 7, that just equals 7. Because the base of the exponent and the base of the log, if they're the same, they cancel each other out in essence.